Well, we have another question here that says write the following in simplest third form without the use of a calculator. Okay, to do that without the use of a calculator, we need to know some rules of exponent and surds. Okay, now let me first give you one. One of the rules is like the nth root, okay, of a to the m. This is equal to a to the power of m over n. Okay, and then sometimes another rule says that I can make another rule here. The nth root of a to the m plus n is equal to the nth root of a to the m multiplied by a to the n. Now, I do that because sometimes if the indices, okay, when you don't see any indices, understand this too. When the indices is even, okay, we can break this, the radicand, the exponent of the radicand into two, odd and even. Let's show you how. Question A, for instance, here, we have like square root of 2 to the power of 11. This can be broken down into what? Square root of 2 to the power of 10 multiplied by 2 to the power of what? Of 1. Okay? We can break it up into 2 like that because all this combined makes 2 to the power of 11. Okay, now let's see. This will be what? Root of 2 to the 10 multiplied by root of 2. And then that makes 2 to the power of 5 root 2. And this is equal to 32 root 2. Okay, and then B, the cube roots of 2 to the 11. Now that the indices is an odd number, we can break it up into like a multiple of 3, the exponents. Okay, so I'm gonna say instead of writing 2 to the power of 11, I prefer to write it like 2 to the power of 9 multiplied by 2 to the power of 2. All this combined makes 11, but I wanted to have a multiple of 3 over here. Now this will be then cube root of 2 to the power of 9, 2 to the power of 9 multiplied by the cube root of 2 squared. And now that makes like 2 to the power of 9 over 3 multiplied by square roots, cube roots of 2 squared, which is 4. And then 2 to the power of 9 is just 2 to the power of 3 cube roots. And then cube roots of, cube roots of 4. And then 2 to the power of 3 just 8. So that makes 8 cube roots of 4. Okay. And then we can do question C. That makes a 405 x to the power of 7. Okay, to solve this, we can simplify 405, 405. Let's see that in the calculator what that's gonna be. If I do square root of 405, this is 9 root 5. So I can write here 9 root 5, and then x to the power of 7, I'll write like x to the power of 6 multiplied by x to the power of 1. Okay, now this will be 9 root 5 multiplied by root x to the 6 multiplied by root x, and then this will make what? X root to the 6 will make x to the power of 3. Okay, so this will be 9 x to the 3 and then roots 5x. Okay, thank you. Well, here they say that the length of a rectangle is √3 plus 1, and its breadth is √3 minus 1. Determine the diagonal of the length of diagonal in third form. Okay. So let's say this is the rectangle. Okay. Now it is said that the length is square root of 3 plus 1, and the breadth is square root of 3 minus 1. Okay. Now the question says determine the length of its diagonal. The diagonal is what we're looking for is this one. I can show the diagonal must be this. I don't really have to be accurate here. Can be it must be this is the diagonal. Okay. Then we do know that diagonal is from that to there, okay? And then rectangle, we do know that the rectangle forms angles of 90 degrees, okay? There, even here, and there. Now, because we have an angle of 90 degrees, basically, you'll notice that over here, we do have a right angle triangle. See, this forms a right angle triangle. Okay, forms like a right angle triangle there. Then where this is the if this is the angle, okay, the opposite side and then the adjacent side, and then that the hypotenuse. Now in parallels, we learn that the length, the longer side of the parallel of a triangle or the hypotenuse, okay, we call it like, we usually call it like C. That's A here and then that B. Okay, we know that C squared will be equal to A squared plus B squared. Okay, so we can say that the longer side C squared will be equal to A squared. So √3 minus 1 to the power of 2 plus B squared. So √3 plus 1 to the power of 2. Now let's simplify this. This will be equal to what? We can apply the properties that says A squared, no, A plus minus B to the power of 2 equal to A squared plus minus 2AB plus B squared. Okay. So when it's plus, it's going to be plus here, and then when it's minus, it's going to be minus there. So if I apply this property, this will be C squared will be equal to what? Let's first work out the first one. So it's going to be like A squared minus 2AB, okay, plus B squared. And then for the next one will be plus A squared plus 2AB plus B squared. Now let's substitute. A here is √3 minus 2AB. A is √3 because this is like A and minus B, and then that A plus B. And then over here, we cannot apply the difference of 2 squared because we don't have a difference here, rather we have a sum. And then we said that there is no formula for the sum of 2 squares. So this is like √3 as I write there, multiplied by 1, and then plus 1 to the power of 2, and then plus on the other side also √3 there, and then 2 √3, and then 1, and then √3 there. Now note that the square root and the power of 3 we cancel, and then also here there, I mean, I don't mean it was √3, but it was 1. Okay, and then this will be so this will be equal to 3 minus 2 root 3 plus 1, okay, plus 3 plus 2 root 3 plus 1. Now we have like these two common here, I mean opposite signs, so we can simplify these, and the answer here will be just 3 plus 3 plus 1 plus 1, which is equal to 8. Okay, thank you. Well, we have another question here, question 4, that says show that this expression equals to -1 without using a calculator. Okay, root 2 minus root 75 over 3 to the power of 3 over 2 equal to -1. So when the question starts by saying show that, it means it is true. We just need to prove that it is true. Now let's see. We can reduce root 12. This is equivalent to say 3 root 2. We can use a calculator for that. Root 12 equal to 2, actually 2 root 3. That makes 2 root 3. If you're unsure, you can do the factor 3. By 2 it's 6, by 2 it's 3, and by 3 it's 1, and that makes 2 squared times 3. So if you square root it, it's gonna be 2 root 3. Okay, and then for 75, this is also negative 5 root 3. Okay, and then there we have like 3 to the power of 3 over 2. This can be written also as a square root of 3 to the power of 3. Remember, we did say that the nth root of a to the m, okay, this is equivalent to a to the m over n. Okay, so this, let's say this is equal to 1, -1, and then we can continue by breaking this denominator. This will be equal to 2 root 3 minus 5 root 3, okay, all over that makes what 3 squared times 3, then equal to -1. Now let's move it a little bit up there. Over here we can say that this is like 2 root 3. Okay, we can take root 3 for the common factor. So this will be like square root of 3, okay, factors of 2 minus 5 all over. At the denominator, we can split it as root of 3 squared multiplied by root of 3 equal to -1. Okay, the numerator then makes root 3 multiplied by -3 all over root 3 multiplied by root 3. I mean 3 multiplied by root 3, okay, equal to -1. Now we can simplify this root 3 with root 3, and then -3 with -3, and then this is equal to -1. This is equal to -1. I don't need to put the equal sign here. This will be a -1 equal to -1 equal to -1. So left hand side equal right hand side. Proven. Thank you. We have another question here, 5. The question says that without using a calculator, show that this expression here is equal to a half. So let me just remind that we do know that a minus b raised to the power of 2 equal to a squared minus 2ab plus b squared. Okay, so we can write it as for the numerator in this question, we write like a squared minus 2 a b plus b squared all over. At the denominator, we can write 6 minus 32 is same as root to the square root of 5. I mean, square root of 2 to the power of 5. Okay, we need to prove that this is equal to a half. Okay. Okay, here the first power of 2. Now, I'm gonna substitute here square root of 2, square root of 2, 1, and then 1 squared there. Now, over here, square root of 2 and the power of 2 will be cancelled out, and then this will be then 2 minus 2 root 2 plus 1 all over 6 minus square root of 2 to the power of 5 can be written as square root of 2 to the power of 4 multiplied by 2 equal to excuse me, a half. Okay, this can be written as we can combine 2 and 1. That makes 3 plus 2 root 2 all over there it will be 6 minus root of 2 to the power of 4. No, I mean root of 2 to the power of 4 multiplied by square root of 2 equal to a half there. And then this makes what? 3 plus 2 root 2 all over 6 minus that makes 4 2 squared, which is 4 root 2. Okay, equal to a half. Now we can take over here we can take 2 for common factor, so this will be what did I, okay, this is not a plus but a negative, sorry, a negative here. It's a negative here, minus there. So at the denominator that I can take so it's like 3 minus 2 root 2 over, at the denominator I can take 2 for common factor, and then that will be 3 minus 2 root 2, okay, equal to a half. Now we can simplify the numerator with this denominator, and then what we have, when we simplify, understand that over here there's an invisible one there that times the whole product, so this will be a half equal to a half. So proven. Left hand side equal to right hand side. Thank you. Well, now for this question now, 6 says simplify, and then we're going to simplify this question, and then square root of 2775 can be written as 5 root 3 minus square root of 50 can be written as 2 root 50 will be 2 root 5. Yeah. No. Yeah. I think I'm mistaken. So square root of 50 will be actually 5 root 2. Yes, 5 root 2. 5 root 2, and then all over. Okay, over here, we can. This is a product that leads to the difference of 2 squares. Okay, so remember the property that says when we have like a minus b and then a plus b, this is equal to a squared minus b squared. So this will be like 100, I mean 10 to the power of 2 minus square root of 5 raised to the power of 2. And then there we can take the numerator, we can take 5. Because it is the common factor, we can take out 5. Okay. Over what? That makes 100 minus 5, because over here the power of 2 will be cancelled with the root. At the numerator, I want to take 5 as for common factor. We have left with root 3 minus root 2, and then this is equal to 5 root 3 minus root 2 all over 95. Okay. Actually, I meant it's not really that I missed the square root here. So this is actually square root of 10 to the power of 2. Yes, so this makes 10 because the square root and the 2 cancel. And the denominator is going to be like over 5. And then we can simplify 5 with 5. And then the simplest form will be square root of 3 minus square root of 2. Thank you.